Okay. Write the area of the triangle in terms of A, B, and C. So now that when we were doing this proof for the law of sines here, okay, we dropped that height segment, okay? When do you want to know what the height of a triangle is? When you want to know its area, right? So this problem is going to lead us to a new formula for calculating the area of a triangle. If they want us to write the area in terms of A, B, and C, A, right, whoops, how about that? Huh. A could be the base if I drop a height segment down like this. So that's what I'm going to do. I'm going to drop a height segment down, try to get it to be perpendicular. Hopefully that looks about right. So I'm going to call this H. Okay, so here's what I know. They want to know the area. Now, area of a triangle is 1/2 base times height. I write it like that. Some people put BH over 2. I write 1/2 base times height. Okay, now in terms of finding this area right now, I don't know the height. I could say that the base is A. All right, so I could, at the very least right now, I could say that this is equal to 1/2 A. Now, in terms of H, I don't know what H is. I've got the area with the variable A involved. So how do I involve B, angle B, and the variable C in this problem? And it's got everything to do with that right triangle stuff that we were doing before, right? Okay, so this angle B, this side C, and this height segment that I just drew right here. Well, we've got right triangles, and if I have angle B, side H, and side C, go off to the side here, we know that the sine of angle B is equal to H over C. All right, so here's my margin work. If I multiply both sides here by C, I get this relationship. And if this is equal to H, I can bring that back into this equation. Now I have the area of the triangle in terms of A, C, and angle B. And the whole point of this formula is being able to find the area without the height. But we have to have that specific combination of sides and the angle. If you notice, right, none of these letters, oops, sorry, I went to go for a different color there. None of these letters match. If they don't match, that means then the two sides that I know form the angle that's also a part of that formula. Okay, so I can find the area of this triangle not just with AC and angle B. I can find it also if I knew, let's say I knew angle C right here. I could express this exact same formula with different variables, right? So if I knew this angle, I'd have to know these two sides. I could say AB times the sine of C. And then, of course, we could also have a third formula. It's the same formula. It's the same relationship. It's two sides and what we call the included angle, right? So when these two sides meet, they form this angle. If you know two sides in the included angle of any triangle, you can use this relationship to calculate the area. I've actually done this and modeled this before for some people on the SAT and the ACT when questions like this come up. It's a nice formula. It's a shorter formula than having to calculate the height using right triangle trig. It's kind of convenient in that regard. Okay.